Okay, so let's just go over shell scripting and chapter 27 in your book. But if you look at the what we do for our shell commands, now this is like the same stuff we've been doing at the prompt and we've been typing in at the terminal, only we can put it into a file and have it and just run it as automated all at once. So this has several benefits to it. Like you can take a several hour setup or process and then do it in seconds, literally. So this lets you automate your workflow, lets you do things really quickly, set things up really fast. You can set up servers. In this case, I do have a server set up here where we can actually have it set up a Apache LAMP server. LAMP is Linux, Apache, MySQL, and PHP. We can actually have this auto set it up for different distributions of Linux. We can tell it which distribution of Linux we're using, and it will set it up for that distribution of Linux. So this is an example. Um, there's a lot more stuff in this book here on this chapter on this stuff, but I wanted to give a real world example of how to use these mechanisms and how to make this work and how to make this happen. So when I'm doing a shell script, I need to tell it what shell I want to use. Now, typically, you're going to use bash anymore these days because bash basically is what we've been using when we type in our shell commands. That is our home shell. Wherever there are different shells, however, bash is used 99.999% of the time now. Basically, it has all the capabilities of all the other shells and it plus more. So for that reason, everybody just chooses bash almost every single time now. Back when there used to be, oh well, there's korn shell and there's tish, sish, etc. And you could use some of these other shells to get some special capabilities or whatnot, but now those capabilities are also in bash. So no one uses those other shells anymore hardly. They just all use bash now. So that makes it simple because we can just pretty much focus on bash. So that makes life easy. Um, Variables are a little different here than they are in some other some other types of programming languages. Shell scripting here can be done to where it does act like a programming language. It does have programming structures, and we can make it do crazy things. So this lets you automate tasks and make decisions, repeat tasks, work through a whole list of things, etc., right inside of this program here. Now, I do want to point something out. The way we do a variable when we're creating it and assigning something to it is we just name it like this right here. And then we can say equals, and then in quotes here is what we're going to put a text string value, right? In this case, it's true because they don't really have a boolean true or false inside of shell scripting like you would think. So I literally typed in the word true. Now I could have set this to a 1. In programming, 1 is true and 0 is false. So I could have done that, and that would work too. But I wanted to be less cryptic and more straightforward to everybody. So I actually typed in true. Now technically, true in quotes here is less efficient and takes longer to execute than a 1 or a 0 would be, honestly. But, you know, this works. If I do want to do this as a 1 and 0, what I have to do instead, now if I put a pound sign here, it comments it out, so it no longer exists. If I wanted to make this into one where I do set it based on a value as I just stated. Notice there's no space here between the equals or whatever. That actually screws things up. This language is different than other languages where spaces actually matter and just all kinds of little tiny things. So you have to be extremely accurate when you type this stuff in. It's not as forgiving as Python is or whatever. Note though, you can also use the OS. You can do import OS or whatever in Python and actually import shell scripting for Linux and actually run shell commands through Python. You can do the same thing for Microsoft Windows and things of that nature. And you can even detect which OS is running when you're running the Python program. Thus, you can make it execute different things for Linux versus Windows, etc. So if you wanted to, you could write something in Python for your networking tools and actually have it do things like batch processes on Windows, which is basically the same kind of thing but less powerful than a Linux shell. You can use batch process where you actually code out something just like this with the scripting with the DOS commands. Essentially, that's what a batch process is in Windows. So you can do the same kind of stuff in Windows, but just not as powerful. But one of the things I would have to do in here is do a -I here in order to make this an integer base value and to declare it. And in doing so, this makes this, I think I have to do, was it -I, like that, I think, if I remember right, something of that nature. I'm going to turn this into an integer. That, or I have to do it here. I'm trying to remember. It's been too long since I've done it. Don't do it very often. But anyhow, that would be necessary if you're wanting to, because otherwise it's just going to be a text value and not a number or whatnot. So you gotta be aware of that. It defaults to text on these variables. So if you just name a variable and assign something to it, it's going to assign text to it and not necessarily a numerical value. So be aware of that. Here I have an if statement. We can test several things in our if statements. Now I could write this a couple different ways. I could say if like this, space, instead of brackets I could say test here, and then I could say $, space, dash, EQ, space, 0, like that. And then I could go on another line and type in then, and then indent yet again for the echo, etc. That's really kind of ugly, quite frankly. So what I did is I did a different trick. Now note I could have also done this too. So I can get away with doing that and then put echo like I was doing below. The test is used in place of the brackets here. I like the brackets because they're more a closer match to parentheses for other programming languages. So this is more standard. The brackets are more standard with what you would see with normal programming language. And the other thing about it is that the semicolon here lets you put multiple commands on the same line. So that way you don't have to basically put them on separate lines each time. This is also useful when you're at the command prompt. You can sit there and run one command after another after another after another in sequence by just putting semicolons and then hit enter, and then it will go through and execute each one after another, and you can go get some food or something like that. Particularly important when you're compiling the kernel and it takes like a couple hours to compile it, and you don't want to sit around for like the next process pops up in 15 minutes or 30 minutes and you have to sit there and babysit it. Instead, what you can do is you can put the commands, separate them by semicolon, hit enter, and then go get lunch or whatever, because it's going to be compiling for 2 hours. If that makes sense. You're not going to be doing that this quarter, but I mean, it's something you do in the second class. You do compiling the kernel. So it matters. It does become really helpful. So if I put the semicolon in front of the then, you notice I don't have to put it on a separate line, and so then it gets to be like a more standardized programming structure if then type conditions. Here we're making a decision as to what to do. If this, then do this. If not, don't do it. So that's basically what we're saying. If this is true, if this condition is true, then we're going to do this code. If it's not true, we're not going to do this code. It's going to skip it. Does that make sense to everybody? Alright, awesome. The $sign here. Alright, the pound sign means how many arguments are passed into the command. To put this another way, this would be the same as when I'm coming here to terminal and say I were to type pwd. That required no inputs. Okay, I didn't put anything into it. I didn't say something like, hold on a second. Alright, for instance, that's one input right there, right? -L. So that was one attribute being passed in. So in that case, the pound sign would have 1 stored in it. In the first case with the pwd, pound sign would have 0 because we didn't pass any extra options into it. Does that make sense? Alright, so when I'm saying options, when I hit space here, see that right there? That was one option where I'm telling ls to do something more than just regular ls. So here I did no options, right? Here I'm telling it to pass, I passed in one option to it, or argument, if you will, one argument, to say it technically. So pound sign basically records how many arguments are passed into your program. Now, because we're writing this as a shell script, we can actually see if anyone typed anything when they ran the shell script or not to go along with the shell script as an argument to it. So we can set it up to where we can process arguments the same way you would an ls-l, for instance. Or, for instance, another way. This cp command or copy command has 2 arguments, right? I can sit there and say /, oh, I don't know, pictures, and then /, I could move it to public maybe or something like that, right? I can copy it from one place to another. Does that make sense? That would be 2 arguments, right? Because here's our first argument that's getting passed in, and this would be our second argument that's getting passed in.
So the first thing that you type in with the CP or the LS is the initial program that you ask
Correct.
for action from.
Right.
And anything additional to that is going to be the
arguments. Correct.
Or the additional commands.
Correct. So just as he said, this is the actual program, the CP is, or the LS is, this actual program. And anything additional beyond that are arguments that are being passed into the program. Does that make sense to everybody? So basically what we can do is we can record how many arguments there are and decide what we need to do. If that makes sense. So that's what we're doing here. It's very powerful, matter of fact. So we're saying here, if there were no arguments, because -eq means equal, right? Now I got a dollar sign in front of the pound sign because I want to access what's stored inside the pound sign. Pound sign is the actual variable itself right here. If I put a dollar sign in front of it, though, I can actually access the contents inside of the pound sign. In this case, it's the number of arguments being passed in. So if I do a -eq here and it's 0, say equals 0. If it equals 0, that's what -eq means. All right, then it means there were no arguments passed in, right? It means they just ran the program with no arguments. Same thing as like just typing in ls and then hitting enter. Does that make sense? We didn't do a -l, we didn't do a -a, we didn't do any of that stuff, right? We just straight ls. We just ran just the program. That is what we just tested. So again, saying no arguments passed in means they just typed in the program and hit enter. If it equals 0. Now, if they have more than this, then we're not going to do this right here. If they did pass an argument in, we're not going to do what the next set of code is. So we're not going to display it. Now, echo does what? It displays something to the screen, right? So that's what we're saying here. We're saying echo, in quotes here, this program sets up and installs a LAMP server. So now we're basically sending them a message to let them know what's going on. And as proof that this actually just kicks out to the screen when we run it. And you can test out these different ones in your terminal as you're designing a script. So that's the kind of the cool part about this. It's like you don't have to work blind. You can come in here and do this right here and see, hey, yeah, it does display it to the screen. Can everybody see that? Yeah. So when I ran echo, this program sets up and installs a LAMP server, blah, 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 right here, right? It came up and it displayed. This is the output from it. This program sets up and installs a LAMP server. What's that? Yeah, and I put it in quotes to let it know that this is text.
And the LAMP is just the Linux Apache
See?
mail server, right?
Yeah. LAMP is Linux, Apache, MySQL, and PHP. Yeah. Yeah, see how I put in quotes right here? These quotes tell it, hey, that this is a string, a text. Basically like a sentence or something like that. It's words, blah, blah, blah. They're referred to as a string in programming. That's what we call them. I don't know why it's referred to as a string, but it always has been. For every programming language, they always refer to it as string. When you're declaring these variables in other languages, you literally type string for the variable type, data type. So shell scripting defaults for the variables to string by default. Now if I put a -n option in here, what this does is it keeps it all on the same line here. So the -n means no carriage return. and line feed, meaning no new line, doesn't go to the next prompt afterwards. You'll notice after the other one, it went to the next prompt. Now if I put a -n in there, that's not going to happen. We're going to get the prompt on the same line. You might be going, well, why on earth would you want that? Well, it actually makes a lot of sense when you're trying to have someone type something in. Let me show you what this does real quick. Alright, so you'll notice that we didn't get a new line after we ran this command. Check it out, my prompt is literally on the same line with the text that we echoed out. Notice that before that didn't happen, right? Our prompt is now here, previously was on its own line, separate from my string of text, which above was this. But this string of text down below, so this is the previous string of text, but this string of text here that we echoed out, as you'll notice, is on the same line with the actual prompt. So they're all on the same line. And that happened because we put that -n option in there. So that way it doesn't go to, a whole nother location. Now that's important because when we do the read command, we're going to read in a value from the user. Alright, so here's our read command. And here we're creating a new variable called Linux distro. And it's a string text variable that can store text input that someone types in. Alright, so the read command basically takes an input from a user for them to type something in. And thus, after they type it in, it stores that value into that variable. I'll show you that too. I don't know. What do we want? How about milkshake? Makes no sense whatsoever, but hey, that works, right? Of course, there's no Linux distribution called milkshake, but whatever. So check it out. If I echo out $, I have to say $, because I'm trying to access the value inside of Linux distro. Milkshake is stored in that variable because that's what I typed at the prompt when it prompted me after I put in the read and I said what the name of the variable was. Does that make sense? Some people are saying absolutely not. It doesn't make any sense at all. Alright. Let me put this another way. Basically, we're declaring an empty variable, a variable we're going to use. Okay. The read is going to take input from what someone types on the prompt here on the screen. Let me show you again. Let me run this one more time here. I should have done that. All right. All right. So here's this right here. It's read. I run this and see I'm at a prompt right now. It's wanting me to input something. I got to type something. Whatever I type is going to get stored into the variable Linux distro. Alright, so this way I can capture what someone types and I can store it. That's really good because then I can later on read what someone stored and make decisions about that. Does that make sense? Okay. So, maybe I do Fedora. So now I'm being realistic, okay? Type in Fedora, so now I know they're doing the Fedora Linux distro versus that of Ubuntu or CentOS, etc. SUSE, Mandriva, whatnot. Make sense? Okay, everybody's on the same page now. Good. And then I can make decisions about that. So once I store that value into this variable, I can then later on use this variable. Now, up above here, and I'm going to break this into pieces so I don't get into too much stuff all at once here. Okay, so I'm going to break this into I'm going to do some other shell scripts that are simpler than this one, and I'm going to come back to this one, okay, because this is going to get too complicated too quick with this script here. Okay, we got to do this more baby steps than what we're doing right now. So remember on this if condition statement up here, we were checking to see if there was any arguments passed in, right? And we determined if there was no arguments, we asked them for what Linux distribution they were using. Okay. Here we're saying, well, else, if there's more than 0 arguments, right? Because if it's not 0 arguments, that means there's more than 0 arguments. Then we said, all right, fine. let's say the Linux distro is equal to the very first argument that they typed in when they ran the program. Does that make sense? So literally what I can do when I run the script, what I can do is say something like space, and then I can give my argument. In this case, I could say Fedora. And Fedora is going to get stored inside of the Linux distro variable, because that is $1. It's the first argument. The second argument would be $2, third argument $3, so on and so forth. Correct. Right. So this skips the whole thing of asking you which distribution of Linux you have or whatever by typing it in. This assumes someone's already used the script before and they just want to skip ahead and go right to it. So if you're familiar with it, then you could just literally type this in as an argument to the script. Now, there's another way. You don't have to use sh. Sh is for if you're running a shell. If you made it executable for the shell script, you could do that right there and run it like a program, and then in which case then you could say your Fedora or whatever if you wanted like that. Or the other options I could type into this thing is CentOS, or I could type in Ubuntu. So right now what we have it scripted up to where we can handle 3 different ones. Is this making sense? Sort of, kind of, no? Alright. We're writing our own program, our own tool, literally. And we've called it lamp.sh and we saved it. Once we do, it color and highlights all this. So literally you go in and you type this up just like this. Okay. And once you do, you say File, Save As, and you save it as something. In this case, we saved it as lamp.sh. The moment I do, all this text highlights up, according for key commands and things of this nature. It recognizes them and color codes it for us, so we know if we mistype something or whatnot. So like for instance, read here is color coded because it's a actual shell command. Same thing goes here for else. If is spelled backwards for the end of your if condition statement. Don't ask me why they do that, but they did. But yeah, for ending the if condition statement, you spell if backwards. You do the same thing with some other structures later on, like case. You spell esac for case for the case statement, but whatever.
Do you do that in other languages as well?
No, just this one. Only this language makes you spell things backwards for ending a condition statement. It's really weird, but also, again, notice I did not put a space when I'm assigning something here. It's very important. If you put a space, it will not work. So it'll mess with you. You can put spaces in other languages. In this language, you cannot put spaces. If you do, it'll make it not work. Yeah, I mean, like if you're doing one of these assignments, man, it has to be all together. You can't put spaces in it. This language is extremely stringent about spaces and punctuation and all this stuff to a degree that's beyond any other scripting or programming language I know. So this one's like really rigid on what you have to type and how you have to type it and all this stuff. They really leave little to no possibility for any variations on it. But so basically, if someone types in Fedora into the program, instead of like just typing in lamp.sh and running it, if they just type in lamp.sh and run it, then they'll get prompted with these questions here saying, hey, which Linux distribution are you using? Are you using CentOS, Ubuntu, or Fedora? And then you would type in, one of those here at the prompt. Now, if you had typed in instead, if you typed in lamp.sh space like Fedora and then ran it, it's not going to ask you that. Why? Because you just told us when we ran the program what version of Linux you're running, and we've decided that we want to handle that. So that way we don't have to worry about it. And the way we store what someone typed in there when they ran the program, lamp.sh space Fedora, is we're doing this whole $1 here. And that's the first argument that was passed into lamp.sh. So does that make sense, everybody? Okay. And the reason we put in quotes is we're trying to make sure that it becomes a string. So we're making sure that it is text, okay, by doing that. So that's why we put the quotes around it. So that's why it's quotes, $1, close quotes. All right, and then again, we ended our if statement by spelling if backwards. So lets us know that, hey, we're not going to do anything else part of this else statement. We're not going to make anything else. How to say it without saying else? We're not going to do anything that will continue on execution outside of the arguments more than 0. That's a really terrible way of saying that. Trying not to say else. It's really messing with me. Because I literally... Here's a really great trick to help you figure out the logic on this stuff. Literally say it like you're thinking or like a sentence, and that makes life so much easier when you're programming. If you want to say, well, if I want to do this, then I need to have it do this, this, and this. Now, just what did I just do? I just literally went in here and said, if I need to do this right here, right, then I need to do this, this, and this. Does that make sense? Else, otherwise, I need to do this right here. Does that make sense? So if you look at programming like that, it's very logical. It's very, very much, you're doing what's called a decision structure in here, okay? And it literally lets you make decisions on whether or not to run this, do this operation, or do that operation, or sets of operations. So fundamentally, that's all you have to do there. That's exactly what we're doing here. And we're just testing if someone typed anything in when they ran this program or not with those ifs. Does that make sense to everybody? Okay. So that's an if-then structure. Now I want to show you there's some other stuff you can do with ifs. That's explained in your book. Your book does a pretty good job introducing the content here. Now I don't think I can do all this in one video. It's 100 pages for this chapter. I'm not kidding you. So I really just don't see how I'm going to get it done easier than that. But you'll notice on 972 here, they do have it where it's echo-n, right? Because it puts it all on the same line. And in quotes, they have word1, colon, space, quotes. Now, why do they put a space there? Well, I did the same thing too. Check it out. I put a space in mine. Why? Because the reason is, if you don't put that space here, remember the dash is going to put it all on the same line, right? So whatever they start typing is literally going to be smack up against whatever it is you left for a statement, right? However, if I put a space there, right? If I put a space here before my quotes, whatever they type is literally spaced out. So at the prompt. So that's the way we want it to be like that, right? And that just makes it cleaner and easier to read. We want to be professional about it. And so that's what allows us to be professional. And they've done the same thing here. In this case, they've done read word1, and then they do echo-n, and then space in quotes, word2, colon, space here again, read word2. So what are they going to read? They're going to read in, someone types in a word on the prompt for the first one, and then ask them to type in word2. They're going to type in another word, hit enter. So now we're going to have word1 and word2 stored in the two variables, word1, word2, etc. And then they're going to do an if test here. So they're going to test to see if the two words are identical. You see that? So it says if test here in quotes $ word1 close quotes equals equals quotes $ word close word2 close quotes. And so what we're doing, we're testing to see if they type the same word twice, both times. If they did, then it says echo match, that the words match it. So you display that it matched, and that's it. You're looking for chapter 27 in your book. Yeah, this could be used for something like a password, where you literally check to see if they typed in the password correctly twice when you're storing their password. Yeah. Yeah, it's actually very useful for that. So it's very important. On page 972. Again, we're on page 972. Echo end of program, and it's just saying that, hey, it's the end of the program. Optionally, what you can also do, it's a really good idea to do it, you could say exit 0 at the very end, and if you do, this is more professional, it lets the operating system know that, hey, this ran without problems. You can do exit 0 like that at the end of your script, and that means that, hey, your script ran without any issues. So that's a good thing. In this case, you can see the running of the program. They've made it executable, and in order to make it executable, you do like chmod space plus x space the name of their script. In our case, it'd be lamp.sh, and they named their program fi1. Now you want to put a .sh for your shell scripts. A couple of reasons why. One, it makes it highlight up like this when you're coding it. Two, it's a shell script, so it should have an extension of .sh. Period. It should. And then we can run it as a shell script with the sh command, which is also not in your book. If you use the sh space and then the name of the shell script .sh, bam. So the extension for your shell script should always be .sh. Again, it's not in your book, but that is something you should do. And then you can see it run here. So they did a ./if1 here, and it says word1 here colon space, and then they typed in peach. And it says word2 colon, and they typed in peach, and then it said match, end of program. So yeah, it verified that two parts of the program were together. Alright, so to do another one was check arguments. Now remember how we just did arguments for our testing our check here? See how they did if test $pound -eq space 0? So we're checking to see were there any arguments passed in to this program. If it says then echo, you must supply at least one argument. Exit 1. Now 1 means it's an error, right? Any values higher than 1 when you exit means it's a certain type of error. Okay, so this is a way of you getting back to the operating system that there was an error. As a matter of fact, it gets logged into the error logs in the operating system when there is one. So this is a great way, if something goes nasty wrong while someone's trying to run a script or whatever, you can actually log it as an error in the error logs so that the network admin can go back, even you necessarily, could go back into the error logs and see what went wrong without having to dive into the script or to the program to find out what the problem is. Does that make sense to everybody? So having these different exit values and stuff like that, let it know that there was an error is pretty good. Later on, probably not today, but we'll get into actually how to redirect messages to the error logs straight up and leave messages in the error logs, which is great. We leave messages to ourselves in the error logs when we're writing our own scripts and everything, and thus we can actually go and check it and see what the problem is in our error logs when things are happening. So that's pretty cool and pretty useful. All right. So, and an echo program is running after the if statement here. So now something I want to point out here. If you do exit 1 here, the program stops running. It errored out. It's not going to continue to execute. So the moment it hits exit 1, that's the end of the program. It just basically quit, crashed, if you will. It quit with an error. Does that make sense? So when they run this program, they do /chk args here, check arguments basically. You must apply at least one argument. Notice they didn't put anything with it, right? And so then it comes out, you must apply one argument, and then it never says program running. It never says program running because it never gets to it because the program exited with an error. Okay. Now in the case of if you do /chk arg space abc, they're passing in one argument called ABC for the text. In which case, now it says program running because it didn't error out because you did pass in one argument. So because that didn't happen, because it wasn't a condition of, hey, we have 0 args, instead we have what? 1 argument. So therefore this condition on this if statement ended up being false, which means we didn't exit the program with an error, which means it did run the echo statement program running instead. Cool. Alright, and then here comes the ones I'm really interested in. And I love this actually. The options on page 973 have some really useful ones. These are special condition test statements. Now we use -eq there to test if it's equal, but we can do some other things too with our good old if statements. We can test whether or not something is a directory with the -d option. So if we say if and then some variable space -d space, and then we can determine whether or not it is a directory. So for instance, if we wanted to, we could actually loop through. We haven't gotten into that. Basically, we can loop through and check to see if every single thing in the directory we're in is whether or not it's a directory or not. If we use the -d option, we could have it be a directory, and then we could echo out necessarily just that directory. So when we run the program, it only displays the directories and none of the files. As an example. So that's useful. Maybe there's some reason you need to see if there's a directory. Maybe you're installing software or whatnot, and you need to see that a directory was created when you went to create the directory that you're going to put your files in. A good example of this, you're setting up a mail server, right? You're going with Dovecot, right? You're setting up their mailbox for the user. You need to know that it actually created the folder for their mailbox, so that way it can store the files for their email in the folder. Now, if you tell it mkdir and it didn't work because you didn't have the right permissions, you need to, after you go create that directory, you really should do a check to see that it's there before you try to do your next operation. Otherwise, your next operation is not going to work. And if you do that check, if you do an if with the -d there, you could let them know, the person running the program, that they are not the right user to be creating this folder and thus don't have the right permissions, and that they need to change users in order to run this program. Does that make sense? So you can let them know. Otherwise, you're going to have a very frustrated person sitting there trying to figure out what's going on. Does that make sense? So the more we communicate with the person using the script, the better results we have. This tends to lead to fewer phone calls to you trying to figure out how to use your program. The better you document stuff and the better that you make it user-friendly means the less headaches and troubles people are going to have using it. The less problems and headaches they have, the less you get bugged about it. Okay. Also means lower costs for the company because they're not having to have someone handle all these phone calls for all these problems. You can eliminate them with useful and helpful programs. Does that make sense? All right, so this is a way of automating your networking tasks. And not only that, but you could also be passing these over to other network admins on the team. And you guys could basically code out several scripts to automate different parts of the tasks for your setup, for your servers, right? And so you want your scripts to be helpful, and you want theirs to be helpful too. Because unless you really want to dig through all their code, all their scripting that they did for each server, that's really annoying. So if they do theirs well documented and they have good user message feedback or whatever to you, and then you do also, then guess what? You're gonna have like very few headaches. You're gonna get stuff going right away. You're not gonna have to call each other and go, "Dude, what did you do this time?" Type thing. You don't want that, right? You want to just get your stuff done and just be done with it, and then be going on to the next thing. Does that make sense? So being professional about this stuff and being clean matters. Okay. So -d is a directory. -e is just checking if something exists at all. So the other one with the -d checks if it's a directory and if it exists. -e determines does it exist. Again, this is on page 973. -f checks to see if it's a file and it exists. Is it a file? It's not a directory, it's a file. Does it exist and is it a file? So 2 requirements. -r. Does it exist and is it readable? Does it have the permissions for it to be able to be read? So that's a good one. Say you need to read the information from that to do something with it. Well, it's good to be able to see that it's actually readable. that you have the right permissions set on the thing. Maybe you went to change the permissions and you want to double check that the permissions actually got set correctly so you can do the next operation. Things like that. So you can test it. Very useful. This one's really useful too. -s exists and has a size greater than 0 bytes. Well, why would you want to know if it has a size greater than 0 bytes? Well, what typically happens with a download that didn't actually happen is that it'll create a file of 0 bytes when you go to download that file. And the file didn't actually download, right? Instead, it just generated this file that has nothing in it. And this happens all the time. So if you do the -s option, you can check that file actually did, in fact, download. And this is something quite common. For instance, you could download a program that you're going to install in the system as an RPM or something of that nature, right? You can do that at command line. There's ways of doing this. We haven't gotten into it besides yum. This is outside of yum. You can actually download a program or whatnot. And you need to verify that that program actually downloaded. So run the -s option afterwards to see that, hey, it's bigger than 0. If you do, after you download it, then you can install it. Because let's face it, if it's not greater than 0, for the download, that means that's an empty file, and that just means that, it's not going to be able to install because there's no program there, right? It's an empty program, there's nothing there, and it really didn't actually install, and so you need to determine what to do from there. You may try a different location for downloading and installing. You may be giving out a message to the user letting them know that something's is amiss. Maybe they don't have their internet connection running, so on and so forth. Things like this. You can tell them to check that. Or you could check it in your script or whatever. So on and so forth. The -w option tests whether or not something exists and is it writable. Are we able to save to it? Are we able to write information to it? And that can matter. Say we need to create a new file or a new script or something like that in something. We need to determine whether it's writable so that we can actually create it. We cannot create a file unless we have write permissions. Okay, so if we need to create files, write permissions really matter, and so that lets you know about that. -x does it exist and is executable. So maybe you download some script that you have a program that you want to run and do this whole installation process, right? But it needs to be executable for you to run it. So you need to check first to see if it's executable. If it's not, you need to give it execute permissions. Like, for instance, you could type in, to give it execute permissions, what you could type would be chmod here +x space the name of the program. In this case, we have lamp.sh. Does that make sense? So, and normally you would do this at the prompt, but you could put it in a script if you wanted to make something executable if you liked. And you can check to see if something's executable. So those are some of the nice standard options. They can also be used with loops and not just if conditions statements here. And they're very powerful. We'll get into using those a little later here. Let's see here, 1 second. Alright, so there's one other structure besides the if-else structure, and that is the good old if, else if, or elif. So if the first condition isn't true, else if this condition, is it true? So we test the first condition. If this is true, then do this right here. And then we're saying, well, else if that's not true, then is this true? Then do this. Else if that wasn't true, then do this, etc. You can keep on going until you get to else, where you're saying, basically, if all that stuff's not true, well, else, then do this. Does that make sense? So basically breaking this down to logic here, let me create a new script real quick, and I'll just like quickly throw this together so that it's easier to understand with the else if. Good example of this is on page 978. So basically what I'm saying in principle is something like this. If this, semicolon, then do blah 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 stuff there. Else if like this, then do this. And then I could keep going with that if I want. I could do another else if, then do that, and then I can say, okay, finally, if none of that other stuff worked, then else. And then I end the whole thing by doing if backwards. Does that make sense? And then I can put whatever test conditions I want inside my ifs and else ifs. So this is whatever I want it to be. Make sense? Okay. So same idea, it's just a little more fancy in a much bigger program like this. Alright, so basically what we're saying here in our own little script here, and we'll get back to this in just a second, but I'm saying on the first one here, I'm saying, hey, if they typed in CentOS, remember that first argument that they could type in, right? We stored it into $Linux distro. Well, we stored it into Linux distro, right? Or if they typed it at the prompt when we asked them to type it in, it was stored there. So we asked them to type in either CentOS, Fedora, or Ubuntu, right? So depending on which one they typed, we're testing it right here. So we're saying if they typed in CentOS, then do all this stuff right here. Literally, we keep going. Yeah, still going. We do all that stuff in blue. We do all of that. Okay. Then we're saying else if $Linux distro, they typed in Fedora, right? So we're saying if it equals Fedora, if that's what they typed in was Fedora, then do scrolling, all that stuff. All that in blue. Yeah, so these can get kind of big if you want it to. Get real big. And we're saying else if again they typed in Ubuntu instead, then we're going to do all that stuff right there. Does that make sense? And if nothing else, then they typed in the wrong stuff. And we have FI here for ending our if statement. I really don't have to worry about them typing in the wrong thing. I'll get into that in just a little bit when I cover loops, because we basically made it impossible for someone to not type in CentOS, Ubuntu, or Fedora. And so I'll get into how that happened. That's why I'm not even doing an else statement. Originally, we did do an else statement to see if someone didn't type in the right thing and told them about it. But with the way this is set up, it's not really possible for someone to type in the wrong thing. If they do type in the wrong thing, they'll automatically be prompted to type in the right thing. And the program will not let them continue on until they type in the right thing. They can keep screwing up over and over again, but they won't get any further in the program until they type in the correct thing. So it's basically how it runs and works. That's why I'm not doing the test condition statement. It's not that I forgot, I just basically know better. You may have noticed that, hey, we got if statements inside of if statements. This is called nested if statements, where we can put logic inside of other pieces of logic. This actually makes a lot of sense. Not at first here to you, but it will in a second. I'm basically saying if, here, let me explain it this way. Okay, so I'm basically saying if I want this done right here, and if this is happening right here, then do these statements, blah, 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 whatever it is. Well, if I'm doing a password like that, it depends on what it is you're doing. Let me see here. What's a good example? Well, in the case of what I was doing on this program here, basically what I'm doing here, I'm saying if they typed in Fedora and they are the administrator, then install these programs. Does that make sense? So first off, I checked to see that they typed in Fedora, so that they want to install Fedora. Then I tested to see if they're the administrator. If they're not the administrator, then I tell them you must be the root the administrator, in order to be successful. After entering in the password for root, rerun sh lamp.sh. Enter your root password. And I literally prompt them for the password and make it move them over into being a root user. Does that make sense? So that's a good example of why you would have nested if condition statements. Does that make sense? Because first we need to know that, hey, they're going to do Fedora. Okay. Then we need to know, hey, are they root? Because you can't install programs unless you are root, right? And that's exactly what we're doing up here. And something I want to point out that I did on this, I did yum install, and I did a -y here, space, and then the name of the program I want to install. In this case, this is a Apache server right here. If I do the -y, this does a forced install. So it doesn't prompt me for, do I want to install this, yes or no. So instead, this thing will literally go through and just install them one after another without keep asking me hit Y, enter Y, enter Y, enter Y, enter Y, enter. After install, after install, after install. It's really annoying. So I put the -y in there and I don't get prompted at all. And it just runs through and just does everything like magic. Does that make sense? So that's the cool thing about this. Literally, when you're done writing the script, you will literally be able to go in, run your script, and if you want to install this Fedora, you type in, sh space lamp.sh for your program, for your script that you wrote, space Fedora, and it'll literally go through and install everything for the LAMP server and start it up and make it run. And you don't have to do anything. And then you can use this over and over again for every server you need to set up. You might go, so what? Well, what if you have a couple hour setup for a server, right? You can script it and have it automatically set it up for you. And do it in a matter of seconds. Literally, maybe minutes. Not kidding you. What would normally be a couple hours, you can literally do it in like a minute or something like that. Or in seconds. I'm not joking you. And so now you can set up servers like this. Really quick. Server after server. Say you get slammed. You go work at a company and suddenly their growth just explodes. And they need servers up immediately, right away, really quick and running on the network. Or otherwise, their website's going down because they're getting hit by so many customers and so many people coming to check out their website. Literally, you have to get the servers up and going really, really quick. Okay? Well, if you have it scripted, you can do that. If you don't have it scripted, you're going to have a tough time, to put it nicely. Okay? You're behind the 8 ball, man. You're going to be busting your butt to get those up as fast as you possibly can. If you script it, though, you can work smarter and not harder. And you can sit back and let the script do the work instead of you typing frantically, mistyping, then trying to hunt down, oh gosh, what did I mistype? Oh no, where did I do it? What script file? Where? Let's go look at the error logs. Oh no, okay, what happened here? Instead, if I script it, it works every single time correctly. I get a perfect server every time, no errors, no mistakes. If I don't script it, I'm going to eventually get mistakes. I'm going to make a typo. I'm human, I'm going to do it. But if I script it out and I work it out, I won't make typos. I won't make mistakes, and it's going to work. It's going to be really fast. It's going to be set up really quickly. Does that make sense? Yeah. So there's a reason to this madness. There's not just this is just a bunch of, whatever. This actually can make a huge difference for you. And it's really cool when you get this one written. So basically, I have written for you guys a script for how to install LAMP server. I even have it do this too, where I actually have it generate the test file for the PHP info, and I automatically install the HTML page into a particular place so that you can test out, run the HTML page in your browser afterwards. So I got a whole video that goes over this LAMP server here. I'm not really so interested in going over LAMP server as I am the shell scripting right now. I got a whole nother video. It's like 2 hours and 10 minutes long that goes over a LAMP server. But essentially, here, let me pull this up real quick. Now you're probably going, well, I'm not connected on the internet. You're right, I'm not on the network, but guess what? I'm running my own web server. So guess what? I can still pull up web pages on my web server, even though I'm not connected to the internet, because I am on my server, on my Apache web server. So literally I can come in here and say localhost, for instance, and bam, there's a web page that's running on my web server. And then what I could do is tell it to go to the info.php page. If I type it right, I can go to it. And so this gives me all the information about what PHP modules are installed on my server. And then that's literally the file I generated on the fly there for configuration. I had it write this web page inside the script and put it into a particular location so I could just pull it up in the web browser with this script. Pretty cool, huh? Yeah. And I did that by doing file redirection. Let me show you real quick. Yeah, so check it out. All I did was a regular echo statement. Remember the echo statements where we were displaying stuff to the prompt or whatever? So remember how you could redirect something to a file by using the greater than sign? So yeah, instead of like displaying it to the prompt, I redirected that into a file. So basically I put that text right here, which is the code for that page right there, and I inserted it into a file called var/www/html/info.php. Does that make sense? So I created a page called info.php right from this prompt, and I told it to override it. So if it already existed, it just overrode it. I'm not appending it. If it didn't exist, it creates it. Cool? Yeah. So here we're mixing basically networking commands with shell logic commands, logic statements. So, if this is happening, if this is set up correctly, blah, 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 hey, then we can go do this next networking operation. If it's not, then we need to do something about it, or we need to let the user know that they need to do something about it. The network administrator in this case that's using our script. Okay. So that's a little bit about else, if, and some of these other ones. A good example is on page 979, which shows whether or not right here they use the -d option here, and they did a -d space, and then quotes here, $1, close quotes, and they're basically checking to see if the first argument that was passed in, if it was a directory or not to the program. So when the person typed in the name of our program space, and then whatever they typed after that, was it a directory? Was it a file? Was it a directory? What was it? In this case, they're checking to see if it's a directory. And then they say, hey, if it is a directory, first argument cannot be a directory. And then you'll notice they did this whole one here, arrow, ampersand 2. This is actually making this get logged as an error message in the log files. Is what that operation does right there. That is how you do that. And then they say usage links file directory. Then they did one arrow, less than sign, ampersand 2, and again that's getting stored as an error message by doing that. Alright. You may notice up above here, oh boy, this is more complicated. They have a $pound-eq space 0-o $pound-gt space 2, and then close brackets, semicolon, then. Now, what is all that? Oh my gosh. Well, okay, so $pound is the number of arguments they passed in, and we're checking to say, hey, is it 0 arguments? All right, so did they pass any arguments in, and if so, was it none at all? So, basically we're checking to see, did they pass in any arguments? Or we're saying, or are the arguments greater than 2? So did they pass in no arguments, or was there more arguments than 2 of them? Does that make sense? If they did, then we say users links file directory echo, and we say 1 greater than and 2 here for error message, and then exit 1 on that too. Basically, the problem here they're saying is that you've passed in either too few arguments or too many. So the program only wants 2 arguments passed into it. And if you pass anything in more than 2 arguments or less than 1 argument, then you get an error message. So this program that they wrote only accepts 1 to 2 arguments. And that if condition statement basically assures that. So very cool. You'll notice later on here they use the not -f and then the file. So we're going to check is file not found or a special file. So we're checking to see if it's not a file. Because -f means file. If we put a not sign in front of it, it means not a file. So that's what's going on there. And then later on down below they have ls-l space $sign file. They have to list the files, count link, etc. So on and so forth. So I thought that was pretty cool, and that was a decent example of that program. You'll notice that -gt means greater than. Now before we were using -eq for equal. So there are several different options we have here. We have -eq, which means equals. We have -gt, which means greater than. We have -lt, which means less than. I think it's I think it's GQ for greater than or equal to. I have to look it up. I can't remember. It's the problem with not using this on a daily basis. I don't. My recommendation out in the field is to use Python and nest shell commands in your Python using the OS import to import to Linux. That's my recommendation. I mean, granted, yes, you can script the whole shell script thing, but the condition statements and the coding, everything in Python is a lot cleaner, nicer, easier to code in actually. And also you can make it object-oriented programming. You can also make it graphical. So you could have like a whole GUI that you actually click on and stuff like that if you wanted to with Python and make it do the stuff underneath the hood, which is nice. So, I mean, there's some definite benefits to using the Python. And don't forget the Python runs on every single operating system out there, so that's nice too. So there's some real benefits to using the Python. But you still need to know this because you'd have to nest it in the Python. They have everything scattered out throughout this book, which is really frustrating. So things don't go in a logical order in here in this chapter. It never has. Hold on a second. Let me see if I can't hunt it down real quick. -ne is not equals. That's not equals right there. I used to have this whole thing typed up until lost it. One second. Okay, so I'm sorry. It is -ge means greater than or equal to, and then -le would be less than or equal to. That's what it is. Sorry, I got the last one right there. Like I said, it's been a long time since I've used it. Alright. You doing alright? Getting it? Kind of tough? Alright. I know, it's not the easiest thing you've done before. If you had a programming class, this is probably more straightforward. If you've never had a programming class, this is probably a lot harder than what you're expecting. And I'm supposed to teach all this in one day, but we'll probably break it out a couple of days because it's too much material to cover in one class. It is. But anyways, instead of using the -eq, we could use any of these right here, just letting you know. So that can be used in its place. Just going to put a pound sign in front of all this so it's commented out. Otherwise, it's going to try to execute this stuff, which is not what I want. Equal to, greater than, less than, not equal would be like that. greater than or equal to, less than or equal to, like so. Make sense? That's the equivalent. That's like the translation. I am making this into a video, so you will have this whole breakdown of all this stuff, so you can go back over it to your heart's content or despair, whichever you want to look at it. I think a lot of people think in despair. Now, this stuff's really cool once you get into it. So at first, it's like, oh my gosh, you gotta be kidding me. But once you get into it, it's really actually quite cool. So one of the things I did earlier, remember we did this if condition statement? We said invalid input true. Let me move this up because it's in the way of the rest of the code, and they're going to get disconnected here in our thought and our logic. All right. I mean, it's not going to hurt the coding. I just want this invalid input equals true closer to this whole statement down here so that it's more logical. So we set it to true right off the bat, all right? So that means this condition here is going to be, the first time we run it, true. Has to be true, right? All right. So we're saying here, while invalid input is true, while they haven't typed in the correct thing, do this. Does that make sense? So right here, it's literally do, and we do it until it's done. Okay? So we're going to do it. We're going to do this code here until it's done. So the done is the end of the loop. Does that make sense to everybody? Okay, cool. So now we're going to do an if test in here. So we're saying if our Linux distro, remember that's the thing they typed in, right? Whether it was at the actual prompt when we told them to type it in, or if they passed it in as an argument to the program when they ran it, right? So either way, so we're saying, did they type in CentOS, or did they type in Ubuntu, or did they type in Fedora, all lowercase for all three of these? So if they did, then we're going to say invalid input equals false. And instead of like continuing to loop or whatnot to do a test, we're going to exit out of our loop immediately because they typed it incorrectly, so we don't need to keep checking. And so we're going to type in break. And when we break, we exit that loop immediately, right away. Does that make sense? Okay, so we're not going to continue to do this code. Otherwise, that means if they didn't type in any of those three, that means they typed in something incorrectly. They've made a typo. Does that make sense to everybody? All right. Otherwise, we're going to do this stuff right here, else. So else, we say echo, you have entered an error. That's what I'm telling them. You've made an error, basically. You must type CentOS, Fedora, or Ubuntu in all lowercase. You typed, and I even show them what they typed so they could see their mistake. Does this make sense? And then it says echo -n here. Which Linux distro do you have? And it's going to be CentOS, Ubuntu, Fedora. So I'll ask them again. And then I read in their input. Linux distro. FI here. And so that goes to it's done. Now notice something about this else here. We never set our invalid input to true to false. So guess what? We're going to check again to see if they typed it incorrectly. So after we let them know, hey, you made a mistake here, you need to type it in correctly. Well, it's going to keep asking me until I type it in correctly. Does that make sense? So the way I make that happen is here, so since I say, hey, the invalid input's still true, it's still invalid, because we haven't tested to see that it is otherwise. I mean, yeah, we let them type it in, but we haven't tested it yet, right? So we need to test it. So it's going to repeat back up here again. We go to our new test here, and we test again. Hey, did they type in CentOS, Ubuntu, or Fedora? If they did, then guess what? Invalid input becomes false, and we break out of the statement, and we don't have to ask them to input it again. However, if they typed it in wrong again for the second time, then guess what? We come down to our else, and we say, you have entered an error. You must type CentOS Fedora or Ubuntu in all lowercase. You typed in, and we tell them what they typed in the next time that they did it wrong. Does that make sense? Right, if they're wrong, we keep doing it. And we'll do this into infinity and beyond as they continue to make mistakes. Until they get it right, we continuously ask them to type it in correctly. And they can be there all day if they want, if they just won't type in CentOS Fedora or Ubuntu in all lowercase. Does that make sense? So that's why I didn't bother to do that else earlier on when I was checking for them doing an error, because I did it up here with the loop. This loop is better because this guarantees that they typed it in correctly. This also means by me putting this up front, I go through less code and actually makes the script run faster. Not like it really matters for this little program, but I mean, I like to code things more efficiently just because I'm gonna typically write these programs that are highly efficient. Yeah. No, they just keep entering it in wrong. It keeps telling them what they did wrong and what the thing is right. It never ends. They can end the program by saying Control C, but that means they don't get to go on to the rest of the program without typing in correctly. And I'll even show it to you. I'll prove it, man. I'll show that it works like this. Alright, so literally, alright, I just need to go into my scripts one. I need to be root also. So let me just go ahead and cd into scripts. Like so, and I'm going to say here su space dash dash password. I think I just mistyped password. Yep, I did. Happy fingers. Alright, there we go. Now if I do my dot slash, now remember, if I want to make this into an executable program, I'm going to say chmod plus x like this, and then I'm going to say something like lamp.sh, and that gives it execute permissions. If I do ls-l here, check it out, we'll see that lamp.sh indeed has execute permissions across everything. So user here, group, everyone. Execute permissions. Now, I could have done something a little different here. If I wanted to, I could have come in here and put a U in front of this. That's going to make it execute permissions only for the user and nothing else. If I put a G in front of this, this will make it execute permissions for the group only and nothing else when I'm adding it. Does that make sense? So that's another one. If I just do plus X, that's execute permissions across the whole board, across everything. It's useful. But after I do that, check it out. All I have to do now is type in. I don't have to say the sh. Otherwise, you have to say the sh in front of it. But if I give it execute permissions, I don't need to anymore. I can just say /lamp.sh, for instance. I run this. Oh, check it out. It says this program sets up and installs a LAMP server. Oh, that's what we just went over earlier, right? It says, which Linux distro do you have? Well, I have Santros, of course. It says you have entered an error. You must type CentOS, Fedora, or Ubuntu in all lowercase. You type Santros. This program sets up and installs a LAMP server. Alright, so which Linux distro do you have? Well, I have CentOS, right? Oh, nope, didn't work, right? Because it's supposed to be all lowercase. You have entered an error, so on and so forth. Does that make sense? Yeah. I mean, I could code to where it's not, but it's a headache to no end. It's easier to do that in something like Python, where you could actually force uppercase or lowercase, whatnot, so that we could take whatever someone inputted and then make it all lowercase, and then you could input it. I don't know of a command to do that inside of Bash shell script. Maybe there is, but I don't know of it. Yeah, you could. In my case, I did. I told him it must be all lowercase. So I let him know that it had to be case sensitive. Some like layman people won't know what case sensitive means, so I typically don't say that. But people who are in the field do know what case sensitive means. So I mean, since this is another network admin, yeah, you could say case sensitive, but I just tend to err on the side of people not knowing stuff. So when I make my information, I make my help messages, I try to make them as straightforward and clear as possible. It's just a good policy. It means you get fewer phone calls and fewer people bugging you about why stuff isn't working. All right, so if I came in here now and I said Fedora, it's actually going to go through and do it. Which it won't be able to, of course, because we're not connected to the internet. But because we'd need to be connected to the internet for it to download and install stuff, and I'm not connected to the internet, so therefore it's not going to work. But I'm just going to go ahead and exit out of this thing here real quick. So it's going to keep trying to install this stuff. Does that make sense to everybody? Cool. So there's an example of why you want to use a while loop and how it works. It will keep going and going and going until its condition is false. All right, so it loops forever until a condition is false. Ever have a program lock up on you? You can't understand why the program locked up. That's because it entered into like a while loop or something like that, or maybe not even necessarily a while loop, but some control structure like a while loop, and it continues to loop forever, and it never exits the loop. That's why your program locked up. Same reason why your operating system locks up, so on and so forth. Essentially, it is entered into a while loop that never ends. It's called an infinite loop. It's called an infinite loop because it will continue to loop till infinity or until your computer breaks, which is a lot sooner than infinity, but too long for your, desires. Let's put it that way. Because let's face it, that computer is going to burn up eventually before you ever reach infinity and beyond. So, but that is what it's called in the industry. It's called an infinite loop because theoretically it is infinite. And you don't want infinite loop. Infinite loops are bad, bad, bad. Your loops should always be able to be exited at some point in time. If you don't, then you basically have coded a program locked up. You can lock up your system. It could end up crashing the operating system. Operating systems have gotten better about not letting programs crash them, but still it could happen. Be aware of that. So don't code infinite loops. You'll do it by mistake. Not necessarily on this, but I mean in the future. At some point in time, if you're coding, you're going to code an infinite loop. Everybody does. But you'll end up killing the program and then fixing it. You step through the code. There's programs where you can literally step through your loops and actually trace them. It's called tracing. It makes life a lot easier. So that is a while loop. There's some other kind of loops too. There's for loops. They're pretty cool. Let's take a look at those. They're in your book. And the for loops can be really nice. They're on page 983. Now, I want to point out something about the for loops. They are a counting loop where they count through stuff, more or less. You have this many items in the list. Let's do each item in that list. Does that make sense? Type thing. We need to go from numbers 1 to 100, counting one by one till we go all the way through all 100 numbers. Does that make sense? So, yeah, exactly. So it goes through each one and iterates over each thing over and over again until you get up to 100. Once you reach 100, it stops. Make sense? That's basically what a for loop is. So they are self-terminating. They have a begin and they have an end. The only way you can create an infinite loop with a for loop is to continuously add to the final number condition for your for loop, and it just continues to grow and grow and grow and grow, and you can never reach that number. Actually, eventually your program will crash because you'll make a number so big it won't be able to be stored in the memory of the computer for that variable, and so by the confines of the computer, you'll exceed the value that can be stored, and then it'll crash that way. So, I mean, you'll either have an infinite, so really not probably possible to create an infinite loop, but regardless, you did crash the program, so that's really bad too. So either you have a lockup or it crashes. Either way, it's not good. It's going to be locked up for a while before it crashes, though. Still got to reach that number, right? It's a pretty big number too, by the way. I think it's for well, it's integer based for these countings. And so if you're doing an integer number, typically it's like negative 32,767 to, I think, positive 32,768. I think is the number range, if I remember off the top of my head. And then you can do an unsigned integer, and it's bigger than that, quite a bit bigger. I think it's like 2 million something. I can't remember exactly. But anyways, unsigned long end, I think it's 2 million something. If you just do unsigned, it's like 65,000. I can't remember. I can't remember. I don't keep those memorized in my head. Somewhat, but not totally. All right. So for instance, here they do this cool one on page 984. Now this is neat. I'm just going to do this as a for loop test here, okay? So let's code this up real quick. So if I do for here, space, and I say fruit, so we're making a new variable called fruit. Does that make sense? In space, apples, oranges, pears, bananas. Alright. So if we do that for, now you may have noticed something like, well, what happened to all this cool highlighting? Notice over here we have all this beautiful highlighting, and we're not getting anything over here, right? That sucks. We gotta save it. That's right, man. We gotta save it and do a .sh. That's important. If we don't do that, we're not gonna see squat. So we gotta do that. So for fruit. .sh. They got a different name for theirs. They just call theirs fruit, but I'm like calling it for fruit because I'm doing a for loop. For fruit or not to fruit. All right, so for fruit in apples, oranges, pears, bananas, because here's our variable, so that's why it's been highlighted up blue, right? And then our special reserved words inside of our shell script are for and in, and here's the different values that we're passing in, and that's why they're in black. Make sense? So if you make a mistake, the color is not the right color. So check it out. You basically have correction checking directly in your scripts as you're typing it. Boy, I wish they had this at the prompts, when you're typing in LS and all that stuff. Wish it would just like light up red. You know what I mean? Because if you made a typo when you guys are like typing or whatever, and you're like first learning stuff, it highlighted it up for you, you would see that you're making a typo. This is not the right color type thing. Well, you do get that when you're doing one of these scripts, but you don't get that at your prompt in your shell script on your actual terminal. I wish we had that in terminals, but we don't. If I'd say do, because remember we're going to do it till it's done. All the loops, we do them till they're done. Okay, that's how we always handle loops. And we're going to say echo here, in quotes, $fruit. All right, so why are we doing this? Remember, can anybody tell me why we have the $sign in front of fruit? Correct. We need to access the value that's stored inside of fruit. We do that by putting a $sign in front of it. Why did we put quotes around $fruit? Right, because we want it to be text. We want it to be a string. Yep. Very good, guys. You're getting this down. So I'm going to do this until it's done. Can anybody guess at what's going to happen when we run this? Correct. It's going to lose every fruit. Are they all going to be on the same line, or are they going to be on different lines? Different lines, because we didn't use the -in option. So therefore, they'll be all on different lines. Yep. See if I can't make some of this hit home for the -in option and whatnot. Alright. So now check it out. Let me show you what happens if I don't do the execute permission. Alright. For fruit, permission denied because I didn't have execute permissions. Does that make sense? So I either have to do a chmod space +x space for fruit.sh, or I can type in sh space for fruit.sh. And there we go. We have our apples, we have our oranges, we have our pears, and we have our bananas. Make sense? Now, what happens if we put the -in option there? It's all going to show up on the same line. You're right. And this is exactly what we do when we want to read in a variable. We put it on the same line with it. Run it again. Check it out. It's apples, oranges, pears, bananas, all smashed together because we didn't put a space. That's why you put the daggone space, guys. Remember that? That's why you do it, right? And then we even have the daggone prompt at the end, too. That sucks. So, there's a couple ways around this. I did that on purpose because I wanted you to see it not pretty at all. Now, I could put a space here. Wouldn't that be nice? So that we have a space between our different fruit when we're typing it out. And then, what should I do about the fact that the prompt's on the same line with it? Anybody want to hazard a guess? You said down here? Right here? Okay, let's see what happens. It's not what we wanted. Okay. So, anybody guess why that happened? I'll walk you through it in just a second here. If I put a space there, check it out. I get spaces between all my text. But still, the problem is that I have the prompt on the same line with it. So now they're spaced out. That's great. But what if I want to have that prompt on its own line? I can't put the echo after this. Why? Because when this is looping through, check it out. We say fruit, store apples and fruit, right? So apples get stored into the fruit variable. And we say echo-n display fruit and then a space. So what's it going to display? It's going to say apples, then a space. And the next line says echo, which does a carriage return, brings it to the next line inside the loop. Then it goes back up and it gets oranges and stores oranges in fruit. All right, and then we echo out oranges with a space, and then we go to the next line here with the echo statement. Does that make sense? We keep doing that for every single one, and that's why we ended up with every fruit on its own line a second ago. So if I wanted to go to its own prompt and not to where it was doing it for every fruit, I would have to do it after the for loop. Does that make sense? You're right. It is the echo statement. You were very close. You were very close. I went ahead and went with it because I wanted everybody to see it because no one else knew either. But you were close. You're probably the closest one in class for getting that. So if I do this after my for loop, right, it's going to go through, it's going to sit there, display every one of the fruits with spaces, and then it's going to go to the next line for the prompt. So that way it's not on the same line with the prompt, and I'll prove it right now. So I save this, I'm going to pull up my terminal. So this is what happens when you do a lot of programming. You're just going to be able to do it off the top of your head. Check it out. I now have apples, oranges, pears, bananas, all spaced out, and I have my prompt on its own line. So knowing when to use the -n, use the echo statement to add a space to something, etc. matters. That's why. Anytime you want to add a space, you use the echo statement, just like you said. That was very good. He figured that out. Like, I didn't tell him. I hadn't said that all day. No one should have known that. It's very good. He figured it out. It's awesome. Yeah, if you do an echo statement and you don't pass anything into it, it's just a blank line. Because by default it has that carriage return into it, right? So because of that, it automatically creates a new space, and that's exactly what he figured out without anyone telling him, which is great. It's not in your book either, but that's what it does. So, does that make sense to everybody? Does it kind of make sense how these loops work now? Okay, cool. Oh yeah, I love this one. This one's really good. You'll like this one. This is one of these where you can see a really good application use of it. All right, so let's do 4 directories. Let's name it up front. Now you notice something I did a second ago here. Ugh. Over here. Now, I should have done it, and I didn't do it, but I should have done it. Couple things I should have done, right? I made some mistakes. When I did this thing, I should have done this right here. So let's bin bash, right? And the other thing I should have done was I should have said, what? What number? 0, because we had no errors. 1 is if we had an error. So we let it know that, hey, we exited with no errors. Okay. On this one right here, I'm going to do a save as real quick. And then we're going to say, let's just call this 4 directories. Or 4 dir. How about that? .sh. So we're going to loop through and test to see if this directory is in here or not. So I'm going to be good. I'm going to say pound exclamation mark / bin / bash. Alright, I was good. I did the shell thing at the beginning, like I should. Told it what shell script I wanted to run this as. That's what the /bin / bash is with the pound sign exclamation mark. Alright. Well, okay, so the pound sign means, hey, don't see this. Exclamation mark means execute this. And we're saying /bin / bash, so we're saying execute it with the bash shell. Okay, so that's basically what we're saying there. Anyways, so 4 here, space, I'm going to say dir. Okay, that's reserved. My mistake. Is input? Input is reserved. That's what I thought. In. Yeah, in is reserved. In. How about in dir? Oh man. Oh no, that's the variable. I'm being an idiot. Sorry. Dir. My apologies. In. In's a real word. And then star here. Star means everything. That's what star means. Okay. And I'm going to go to the next line here. I'm going to say do because I'm going to do it till it's done again. If, in brackets, -d. What's the -d do, guys? Yep, lets me test for a directory. And I'm going to say quotes here, $, dir, close quotes, like so, space, bracket. Notice those spaces, those are really important. I'm not going to put the then on a separate freaking line. Semicolon there, space then, like so. Tab it again. Always do my tabs. You make sure you tab things over, right? You want to be organized. I'll give you a story here in just a second of actually happened. It's real, and it makes a big difference. Just to point out why it matters so much. dir here, like so. So I'm going to display the directories. It's going to be a directory on each line separately. I'm not going to have any pretty handling of it or whatnot, but whatever. Fi to end that if statement, and then I'm going to do it till it's done. And then come down here and I'm going to exit 0 at the end of that program. Alright, so can anyone tell me what's going to happen when I run this script? Well, first off, let me explain something here with the for loop, because this isn't fair. Essentially what this for loop is going to do is it's going to go through here and see all the stuff that's stored in a directory when I run this. Whatever directory I run this in, it's going to test it, right? And it's going to, each thing that we run into, it's going to get stored into dir, to the variable dir. So every time we encounter a new item that's in this directory, it's going to get put into dir, and then whatever happens, it's going to, whatever it is, it's going to get tested in this code with this if condition statement. So can now anyone tell me what's going to happen? It's going to list what? It's going to show all the directories inside the directory we're in. It won't show any of the files. List is another way of doing it. But it's list without, basically it's list without the files. It's list with only the directories. Yeah. So we made our own custom list. As far as that goes. If you do an ls, you'll get the files and the directories. But this is list without that, so for dir. and we got nothing. Well, why is that? Well, if I do an ls, you'll see real quick. Oh, that's because everything's files in here. Makes sense? So we didn't get anything. Well, what if we swap that around real quick? What if we change that from a D to an F? It's going to show me all the files. Right. Let me save that real quick. Come over here. So helps if I don't type stuff like that. Alright. Enter. There's all the files listed in that directory. Make sense? So pretty powerful and pretty cool. This is really neat because this is a way of checking all the different things that are in a directory and seeing, hey, is this a directory, is this a folder, blah, blah, blah. Like, did I create it? Did this already exist there? Hey, I need to see if this is a directory and if it's over here in this location. Or do I need to install this app because it's this program because it's not there? Or whatever. Do I need to create it or whatnot, etc. So it's pretty daggone useful. What's that? Uh, uh Well, right now I'm doing this through a script here. So this is a script I ran to check it. If I wanted to, I could come in here and put another if condition statement inside of this to then test if it's a particular directory. So for instance, I could test to see if dir, your $dir is a match to something else. As an example, so let's pick out a file, lamp.sh. Okay, how about that, right? So I'm still going to display the files here, okay? But I'll just ad-lib something into here, okay? So if in brackets, and I say quotes here, $dir, close quotes here, equals, in quotes, like so, because I need to test it as a string for it or whatnot. Okay, and then say if it's lamp.sh, like so, then echo, this is my awesome script. I don't know, it's stupid, I don't care. But it gets the point across. FI. Does that make sense? So we're going to continue the loop. We're going to test to see if it's a file, and then if it's a file, we test to see if it's this particular file. Yeah. Wouldn't it end the other one? Oh, good. Awesome. Then I just brought up a great example for everybody then. Okay, so this is nested if statements. So the way this works is we work out the inner ones first, and then we go outer on the structure. So essentially what's happening here is these inner ones are going to be done first. So this is why you need to tab it. Otherwise, if you don't tab stuff over, good luck figuring out where things begin and end. Okay? It's a professional way to do it. You always be professional on this stuff. Matter of fact, we have no tolerance for people who aren't professional. I'll get into an example of that and what's happened in the past in the field that's so important on this. So being professional is really, really important on this. In America, we have like no patience for unprofessionalism on this, on coding in the field. I'll get into it in just a second. There's a reason for it. All right. So if here, this gets tested here, and then we end that if. And then this other if ends when we get to the other fi. Does that make sense? So that's why we tabbed it. So that way, if it's nested, we can have things nested as many times as we like. Okay, of course, it gets to be unmanageable after a while, but you can do it. Not a good idea to do that, but you can do it. It's no problem having things nested a lot, but if you have something super nested like that, it's a good idea to start breaking things into functions. We haven't gotten into that, but basically it's a way of like taking a block of code out and then just being able to call it by a single line of code for that whole set of code, and then this way you can really reduce the amount of code you have to use. It also makes things reusable, makes it where you have less errors, makes you code faster, lets you do all this stuff. It's really awesome. Yeah, modules, functions, same thing. Yeah. Sometimes referred to as procedures also. That's the same thing. Okay, so this is cool. This will run. And then let me give you basically what went down in the industry. All right, so check this out. It goes through, and the moment it finds lamp.sh, it displays, this is my awesome script with exclamation marks. Doesn't do that for any of the other files, just for that file. Make sense? So that's an example of nesting and why you would do it. Pretty cool. Matter of fact, if you nest things like this, it actually makes it more efficient because then you skip whole blocks of code. So it actually makes things run faster, believe it or not. I'm not going to get into it real deep or whatever, but yeah, it does. It's called binary conditional state. I'm not going to get binary conditional statements. Yeah, makes it run faster. Decision structures, binary decision structures. But anyways, okay, so what's happened in the past? And why coding and scripting is so important, why you use comments, why you tab things, why you use good names. This is what's called descriptive names. I call it dir for directory for short right here. You know, that's why I did that, because it's descriptive. So that way someone doesn't have to sit there and try to figure out what I is or what X is or Z is or whatever. It makes it easy to understand without having to like go back and look it up what a variable was named, what's called something. And then you don't have to write as many comments if you use descriptive variables, because people know what dir is. If I'm counting through a loop and I use the word count for my variable, then we know this is the variable that counts. Makes sense. If this is look, for the way I wrote this things right here, I said invalid input. Okay, so this is going to be, I named my variable invalid input. Do I need to really put a comment that this is invalid input? Not really, because it's what I named the variable, right? Linux distro. Gee, I wonder what this variable is for, right? I didn't name it X. I named it Linux distro, right? So now I probably have a good guess that, hey, this stores the Linux distro that they chose, right? Makes sense. So using descriptive variables matters a lot. Back in the early days, people would write code with no descriptive variables and no comments. So you would get variables like X, T, Z, ZZ, ZZZ, C, A throughout the whole program. No comments. Oh, by the way, they also didn't format either. So you'd have multiple lines of code on the same line. This whole fun stuff, and you get this huge garbled mesh. They also did these wonderful jump statements and stuff where they jump randomly through the code at different points. And it was called spaghetti code. It got so bad when they have basically eliminated the ability to do jump statements in programs because it was such a big problem with doing it. It was near impossible to debug it. It got so bad with those statements and that kind of coding that companies would have to scrap the entire software that they had written, had someone develop, and have to rewrite it from scratch because it was just such a mess. There was just not even. It was actually faster and easier to wipe it and then start from scratch again. Programmers would be so messy on purpose in order to help keep from getting fired as job security. So they'd have to fire one of these guys because they decided they weren't going to do anything or whatever. You know what I mean? And they were just horrible to work with or whatnot. They'd fire them, and then no one could read their code. And sometimes the programmer who wrote it couldn't read their own code later on. And they'd have to go back and rewrite it because they couldn't remember what they wrote or what they were doing at the time. And because they put all this stuff on one line like this and whatnot and didn't format and didn't do all this stuff, they couldn't find their own bugs and their own errors because there was no formatting. Check this out. I can tell that if I left off a IF now, can't I? Because I formatted this, right? It's pretty obvious I left it out. True story. My first programming job. I was doing an infrared sensor into a database system running in Pascal programming language. There's a programming language called Pascal. It's actually quite cool. It's a good programming language. I was coding it. The original programmer had an accident on his motorcycle. He wasn't wearing a helmet. He wasn't all there afterwards. Not sure he was all there to start with, but he absolutely wasn't all there afterwards. He just wasn't the same, as they put it. I got his code, and he somehow found a compiler that would let him compile his code without checking the code. I don't know how he found one. I don't know how ancient that thing must have been, but he managed to somehow find a compiler that would let him code. I pulled up probably about 50,000 syntax errors, were typos. I found about 50,000 typos. Now, mind you, the program is only about 10,000 lines long of code. So there's about 50,000 typos in the program. And then he didn't format it either. So he'd had like 8 lines of code on a single line. And then he named his variables X, Z, ZZZ, T, Y, blah, blah, blah throughout the entire program. And top it off, he didn't write comments either. I spent 6 weeks just formatting his code. His code literally went off the page because he did such a poor job in code and format. I found 50 logic errors where he just started if condition statements like this and never ended them like that. Created loops that never ended, just kept going for the whole program. Yeah, sort of, kind of not. They would run the program and the different parts would just lock up. I'm like, yeah, no wonder. Yeah, I know why it locked up. He didn't ever finish that statement. I finished it, and so I fixed umpteen of it. So all the software ran like totally perfectly smooth and fine, no problems, no bugs. After I was done with it, I spent quite a bit of time. I think I spent forever just formatting it. I was going to try to comment the thing and whatnot. I threw my hands up after a while because I wasn't going to try to decipher what X, TTT, ZZZ was and all that stuff after a while. But I did go through and fix it and make it all work. And it's just because I was organized and clean and professional about it, and he wasn't, and that's why he couldn't make his stuff work. So even with the motorcycle accident, I think he could have made it work had he have been professional and had he formatted his code. But his code was literally unreadable. You could not read it. So this is why you're going to keep your stuff clean and concise. At this point, if someone goes in with sloppy code like that, you will not get hired. Straight up, they won't hire you because they don't want to go through those headaches and that hell. Right? They've already gone through all that stuff with previous people. All right? So they have no patience for it whatsoever in history. Now they're like super anal about it being super clean, super neat, super well commented, super everything. Does that make sense? They have to be because of all the stuff that's gone in the past. And yeah, go ahead. Yeah, it makes it easier to read by spacing it out like this. If I mash everything together, it starts to become harder to read. Yeah, I can do that. I mean, nope, it doesn't make a difference in the way it ran, or the way it runs, but it does make a difference in you be able to read it. So again, like I said, everyone's super anal. Like, so I'm doing this condition statement here. I like to break my condition from the other statements here because it makes it easy to read. Now, if I have it laid out like this, suddenly it's easy to read. Does that make sense? So the more stuff you can do to keep things clean, neat, professional, by all means. If you have your stuff looks really clean and professional, that says a lot about you coding stuff. It means you got a much better chance of getting hired, a whole lot better chance. If your stuff looks like it's all over the place, things are improperly named, whatever, they're not going to want to hire you. They're not going to want you on the team because you have to work with them, and they don't want to go clean up your stuff constantly and constantly have to fix your problems and all that because that's exactly what they're going to be doing if they hire you, and they know it, and they're not going to want to put up with that, so they won't hire you, type thing. Right, you just do a pound in front of it, yeah. So for instance, in here, I could come in here and say, um, I could even be descriptive about it if I want. I could come in here and say pound, check, helps if I spell correctly, right? Check to see if the items folder are files. For instance, I could do that. I'd probably put a space in front of the prompt just to be a little prettier. Makes it a little easier to read. So I mean, you have to get picky about the stuff because of just the stuff that's gone on in the past and whatnot in the field. But if I'm real clean about this and everything, now it's really easy to understand and follow, etc. It's the way you want to code. You want to code where it's clean and easy to understand. The better job you do of that, the easier it is to understand. See, I even came in here and said this installs our lamp setup, blah, blah, blah. I could come in here, since this may be confusing to people, I could come in here and say pound checks to see if the user is root or not. Is the administrator is another way I could have written it. Does that make sense? So I could put checks to see if they want to install CentOS, lamp for CentOS, etc. I mean, if it's like, if there's any chance for confusion, checks if the user is the person using the program, standard term form in the field. See if the user wants to install lamp for CentOS. CentOS or CentOS, depending on how you want to say it. I've heard it pronounced both ways, so whatever. But there you go. See, I even broke up my comments like this. This is fancy right here, but it makes it pretty and clean. So the better and prettier you make your comments, the more professional it looks. Being honest. I mean, I could even get real fancy with it down here, and we could do stuff like we could start spacing this out, so we center it. You know what I mean? Come in here, bring a pound sign to the end there. Do another pound sign. You know what I mean? So like that. We can end it with some pound signs. That's a little fancier. And that looks even more professional. You know what I mean? So if you sit there and lay out your comments, and so the reason why you would do something like this down here, like, well, that's kind of crazy. Actually, it makes a whole lot of sense, and the reasoning for it, and you're like, well, I don't want to type that out every time. You don't have to, dude. Just come in here like this, and copy and paste. Ta-da! It doesn't have to be like brain surgery to pull this off. It's really easy to get something like this set up and making it look good. All right, pounds.
Going into a position, you would want to have something like this typed up to show them how you do code.
Yeah. You want to show how you code and show them that you're a clean coder and you comment things well and all that stuff, without a doubt. Yeah. And see right here, but the point of having comments like this, check it out, is that it makes it real easy to read and find that section. So if I'm just like scrolling through this file, you might go, well, that's just ridiculous to be that, blah, blah, blah. Well, check it out. If I'm scrolling through this file, look what pops out at my eyes. I can instantly find what I'm looking for without really hunting for it. Does that make sense? So you might be going, oh, that's ridiculous, but honestly, once you start getting these script files that are like 1,000, several thousand lines long, I've written one program that's 1,000,000 lines long. I've written several others that are 100,000 lines long. Things like that. Once you have that much code, and it's not in a single file, okay, so it's broken up into multiple files. You wouldn't write 1,000,000 lines in one file unless you're just evil. To be honest, you're not going to do that. But by having this blocked out like this, I can easily find what I'm looking for. Although it is typical for me to write a code file where it's several thousand lines long. That's not uncommon. So having it broken up like this lets you find things quickly and easily, which means you're not spending forever hunting stuff down. So that's ideal, and that's what you want. There's a couple others. They start going over while. We just went over while, so we don't really need to go over it again. The until. Until is just like while, only it does it until it's true. So it continues the loop while it's false. So it does this set of statements until it's true and then exits. So literally, what you could do, there's really no need for an until, and that's why most programming languages now eliminate until. statement because it's stupid. Because if honestly, if I want this thing to not be true, I simply put an exclamation mark in front of it. Ta-da! Now it's false until true. That's all you have to do. It's that easy. So there's really no reason for an until statement. But some programmers dislike the until because they don't want to put an exclamation mark in front of something. It's just really annoying, but whatever. I agree, it does. It also means you have less code to remember for special commands and things of that nature. So other people can write. So I think it's a good deal if you have less commands. But for those, like, if you ever look at basic, huh? Yeah, it's work smarter, not harder. Exactly. Basic, like, put all the different variations of basic things you could do for instead of like putting a not sign in front of something like that. They got umpteen commands for you to memorize. It's really frustrating. It's a lot of code to remember, and all of it can be easily remedied just by some very simple logic to eliminate it. So if you look at Pascal, it's way simpler for the language, and you just have to be a little bit smarter, not much smarter, like just like hair smarter to do the logic. And I just don't understand why people can't put an exclamation mark from the equal sign or the other option there in order to make it not true. But anyways, that's all you have to do. But basically, this would be the same thing as your while loop, only it's going to be, I would have to set this to false. So literally, it's going to look like this. I would need to set that to false though, so it'd be false all the time. Yeah, as far as that goes, more or less. Does that make sense? Otherwise, it's not going to work. Otherwise, I could do this here, etc., etc. But basically, you get the idea. That's what the until statement is. And it's literally no different than the while, other than the fact that it continues to loop while it's false, and the moment it becomes true, it exits. Whereas the while loop loops while it's true, and the moment it becomes false for the test condition, it exits. So they're almost identical, not quite, but daggone close. That's until. Showed you break. Did not go over continue. On page 992, you'll see the continue statement here. So, right here they have it going through and looping through a whole set of numbers. And the moment that it finds that it's less than or equal to 3, then it says continue. And so it doesn't actually display out the number, right? Because it never makes it to echo. The continue is not the same thing as a break. Continue skips a loop iteration. So, break makes you exit out of the loop, but continue skips the rest of that loop iteration. So the moment we hit continue, it doesn't do the rest of the stuff that's in that loop. It skips it and then goes to the next iteration automatically. So let's talk through it. So they run this little program here, and you'll notice up here. So we start with index M1, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. You're going through all the way through 10, right? So index becomes what? What value does index store, guys? Well, first iteration here, what's it store? 1, right. So index stores 1. And so we say if index is less than or equal to 3. Is index less than or equal to 3, guys? Yes, because basically what we're asking, is 1 less than or equal to 3? Yes, 1 is less than 3, so that's true, right? So it says, okay, echo continue, and then continue. So notice it didn't output the number. It never did echo $index because it skipped it, right? So it goes up to the next one. On our next loop iteration, what is index equal to? 2, right? So 2 is stored into index. So we say if $index is it less than or equal to 3? And yes, 2 is less than or equal to 3. Right? So then it's going to echo out continue, and it's going to continue. It's going to skip that loop iteration. Then we're going to go to the next one, right? Index is now has what stored in it? 3. Right. Is index less than or equal to 3? Yes. 3 is less than or equal to 3. It's equal to 3, so yeah. So it's going to display continue, and then it's going to use the continue to skip that loop iteration. Excuse me. So it goes to the next loop iteration. Index, it has what stored into it now? 4, right. So if here we have $index is 4 less than or equal to 3? No. 4 is not less than or equal to 3, so it echoes out 4. See that 4 there? When they're running it? There you go. Then it goes and does the next check now. If index is greater than or equal to 8, then break. Echo out break, and then actually break out of the loop. Is 4 greater than or equal to 8? No, so we're not going to do that. So go to our next loop iteration. Index has what stored in it? 5. Is index less than or equal to 3? No. So then we go to echo $index, outputs it. We get 5. Is index greater than or equal to 8? No. That's right. 5 is not greater than or equal to 8. That's right. So we go to our next loop iteration. What's index equal to now? 6. So 6 is stored in index. Is index less than or equal to 3? No. So we're going to echo out our index. So we get 6. Is 6 greater than or equal to 8? No. So we're not going to do that. We're going to go to our next loop iteration. What's index equal to? 7. Is index less than or equal to 3? No. We're saying is 7 less than or equal to 3? No, it's not. Echo $index, it means we're going to display 7. Alright, so if $index is greater than or equal to 8, so what is that going to be? No, because 7 is not greater than or equal to 8. So that's correct. So we display 7. Then we go back up to our next loop iteration. Index has what stored in it? 8. Is index less than or equal to 3? No, it's not. 8 is not less than or equal to 3. Someone's messing with us now. Echo here. 8. So it displays 8. We get down to our if statement. Is index greater than or equal to 8? Yes, 8 is greater than or equal to 8. It's equal to it. So therefore we echo out break, and then we break out of the loop, and we never make it to the next loop iteration for it to be stored 9 or 10. We never make it that far because we exited out of the loop. Does that make sense to everybody? So it's a good example of the continue and break statements. I'm not getting into case today. Alright, I just want to break down real quick the rest of the script here on the lamp, and then we will leave the classroom. So we already went over the whole if statement here, invalid input, went over this while loop, what's happening there. We went over actually this whole if statement here for CentOS, checking it to see if it's CentOS. We basically did this check. Now remember what $home does, right? If I go to the prompt, this is really quite cool. Check it out. If I say echo $home, all caps, like this, check it out, it says I'm in /root. That is my home directory. Now check this out. If I su into student, and I say echo $home, like this, we get /home/student. This is my home directory. So check it out. When we are root privileged, when we are root, our home directory is /root. So basically, I can check to see if someone is logged in as root or not by checking to see what their home directory is. Does that make sense to everybody? So if their home directory is /root, that means they are the network administrator. They are logged in as root. Even if it's temporary through su /. That's exactly what I've done here. So by checking $home, see if it's equivalent to /root, I basically test to see if they are root privileged, if they're the administrator or not. If they are, that means they can do all these installs after it. I then proceed to install the Apache web server, the MySQL client, the MySQL server, PHP graphics library right here for doing like image resizing and things of that nature. PHP common, encrypt for encrypting things, PHP pair for login system, PHP PLC and memcache for memcaching, PHP mhash for skins has to do with basically security for hashing things, goes along with encryption. PHP MySQL, so I can connect to the database system, a database server. In this case, MySQL is the database server, and PHP XML, which is a data format. Here I'm just installing Python for another programming language to be used. Can be used with Apache if you like. And then here, I'm coming down here and I'm starting the Apache server. I'm turning it on, and then I'm starting it up. And that's what's happening right here. And then right here, I am turning on the MySQL server, and I'm starting it up. At this point, I am generating that PHP info, one that I went over earlier. Else, I already went over this. They didn't. They weren't root. So otherwise, we know they're not root, and so we throw up an error message. So end of root administrator test. End of CentOS installation. So Fedora, we do the same check again. We test to see if they typed in Fedora, and we see if they are root. If they are root, we're going to do the exact same installs. Only we're going to add PHP admin because it's awesome. It lets you basically use a web page to be the administrator of your database system for your database server without having to type a bunch of commands, which is nice. Lets you back up the database system, lets you export it, all this stuff. Lets you do a whole lot of administrative features. Now, yum install Python. You can't do that in CentOS. It doesn't know where it is. You have to do a special download and install. It's a pain. So yeah, you can't just yum install it for CentOS. And then on the new Fedora, it's different. We can't use these commands like we used to. On the older Fedora, like Fedora 12, you would use these commands. But on the newer one, we have to use, like on 17, we have to use these commands here. So we have to use systemctl enable space httpd.service, systemctl space start space httpd.service. But you'll notice mostly this is the same for this stuff. Systemctl enable mysql d.service and systemctl start space mysql d.service. This lets you turn on and start your MySQL database server, and then this lets you turn on and start your Apache server. Again, we generate the PHP info file, etc., and put it into its proper location. And we let them know that they need to be root. Over here for the Ubuntu one, right here, if they typed in Ubuntu, we need to do Ubuntu. Now notice I don't need to check if they're root. I don't have to worry about it because I'm doing sudo. If they are not root, it's going to prompt them for the password. And you'll have to type in the password. And then thereafter, it automatically sudos without prompting them for the password for each and every one after that. Does it make sense? So I have a built-in administrative setup here. I'm using app-get because they don't have yum for Ubuntu. For a Debian system, they have app-get space install. And then for Apache, it's not HTTPD. It's actually Apache 2 MySQL-server, same thing, MySQL. PHP with a 5 in front of it because version 5 is what we're on. So instead of just being PHP, it's PHP 5. And you put the 5 in there in front of each one. Otherwise, it's identical to that of Fedora and CentOS for the names on that stuff for the installs. Also, you have PHP myadmin in here as before. Here's our Python one. And then all you have to do in order to start it, because they have a totally different system in Ubuntu for administrating services, so you just literally start the service. In this case, Apache 2, and this one is MySQL server. And then when you install it to a different location for your file here, because the document root is in a different location on Ubuntu than it is on Fedora and on CentOS. So it's in /var/www instead of like on CentOS and on Fedora, it's in /var/www/html. So that's why we put the info.php file there. Basically, that's it. And that's the end of that if statement. And then so if you type in one of those three, it'll do the install, turn it on, make the server run for one of those 3 different distributions of Linux. Of course, you could add on additional distributions of Linux on this if you wanted, like SUSE, Mandriva, etc. to it, if you liked. Any questions? Alright, next week we'll cover more scripting. And don't forget, next week there's also a quiz. So please study your shell commands. Yes, study those shell commands like crazy. You're going to do it on paper. No, it's not open book.
How about open note?
You can not open note. You can use open brain, where you take the thoughts from your head to answer the questions.